From Trimble Construction, you're listening to the Connected Construction Show, where we connect you to the contractors, owners, designers, engineers, and construction professionals who are finding better ways to work. And now, here's your host, Matt Sprague.
Hello and welcome back to the Connected Construction Show. My name is Matt Sprague and I'm your host. Today's episode, we're very, very excited. We have the founder and chairman of BuildingSMART, Patrick MacLeamy, with us today. Patrick, hello and welcome to the show.
Matt, and hello, everyone. I'm very happy to be here. Thank you for having me.
Awesome. So before we get started, we're in today's episode, we're really going to explore everything that is BuildingSMART, what it is, what it's about, how it was founded, and we're really going to leverage, obviously, you being the founder to be able to help tell that story. Before we get going there, why don't we tell everybody a little bit more about yourself, about what your background is, and how you got to where you are today.
Matt, thank you. Yes, I am an architect and very happy to be an architect. I'm not a technical person at all. I'm old enough, as everybody can tell. I was traditionally trained as an architect, designing three-dimensional buildings on two-dimensional sheets of paper, which would involve compromise, which actually is one of the things that led me to the founding of BuildingSMART. So I practiced architecture and still do, actually, but not for money. I just help out on occasion. I practiced architecture at one firm for 50 years. I started at HOK right out of graduate school. HOK is now a global firm, but then it was one small office in St. Louis, Missouri, led by three extraordinary men. And shortly after I started, I was transferred to their first branch office in San Francisco, where I continued to work as a designer, and eventually became a manager, then the leader of the San Francisco office. As the firm expanded, I became the leader of the Pacific Rim offices, not only West Coast, but Asian offices, which were new at that time, and eventually became the CEO and chairman of HOK, which today has about 2,000 people and 27 locations around the world. People may not know too much about us, or if you do, it may be because, let's say, of our sports architecture. That represents about 10% of the firm's business. The other 90% is a whole mix of healthcare work and aviation, airport design, and research laboratories, university campuses, things that we practice around the world. It was an exciting career, and again, I'm happy I was and am an architect, and BuildingSMART was an outgrowth of, let's say, my frustrations with the practice. What happens when an architect attempts to design and then convey information about that design to a contractor or to a consultant like a structural or a mechanical engineer? What happens? What's missing? And that frustration eventually led to the creation of BuildingSMART.
So that's a perfect segue into let's dive into BuildingSMART. For someone that knows nothing about it, so what is BuildingSMART? And then and you just started to touch on it. What was the original thing that you were trying to change?
Okay, and this is it's a good question, and it's a good story, I think. My original idea was that, if we created this organization and we had all the players at the same table. This is early days of the computer, about midway through my career as an architect, about 25 years in. I had become so frustrated that we couldn't seem to document our buildings well enough on drawings and in specifications to allow the contractor to have all the information that they needed to build. It was always imperfect or imprecise. And I thought the problem was geometry. That is, we were using two-dimensional paper. So just about the time that my frustration boiled over, Microsoft came out with something called object technology. I'm not going to make a big deal out of this, but basically, buildings are made out of objects. A door is an object, a window is an object, a wall is an object. And if we could actually, I had conversations with others in the field, if we could actually describe those objects in computer language, which again, this is not my area, in things to make a computer, which is really dumb as a doorpost, unless you tell it what to do. If you tell a computer what to do, it's a fantastic machine. If you don't tell it what to do, it can't help you. So we had to describe these objects like doors, windows, and walls in discussions with each other, first in plain English. What is a door? Let me just give you some idea about it. Characteristics of a door. Well, a door is, we all know what it is. We all know what it looks like. A door has some geometry aspects. It has height, width, and thickness. And it has lots of other characteristics, like is it a wood door, a steel door, a glass door, et cetera, many permutations, combinations. And it has relationships to other smart objects, such as a wall. You won't find doors unless there's a wall. And the wall, if it's a smart wall, knows, oh, if there's a door, I need to make a hole for the door to fit in. Those are really simple little ideas, but basically, if we can explain that to the computer and put it in very simple terms, the computer will then understand if the architect is placing a door in a floor plan, let's say, that the wall has to make a void or an opening for that door to fit. Very simple idea. No one had ever actually documented this. My first question is, well, we had the budding software industry and software companies that were serving our field, but why didn't they do this? Well, they did, but they didn't do it for the whole industry. They did it for architects. Others, competitors, maybe did software for the engineers, and yet other companies did software for the contractor. So we had a Tower of Babel. We were all looking for ways to tell the computer how to help us with our designing, engineering, and construction, but the computers were not talking to each other. So I learned a new word there that's 25 years ago, almost 30 now, called interoperability. We used to make a joke in early days of BuildingSMART, if you could spell interoperability correctly, we'll make you a vice president of the organization right off the bat. But it basically meant that the software companies were designing software for the architect, but the software couldn't completely exchange the right information, the needed complete information, with the software that's being used by the engineers or the contractors. So we had to find a way to knit it together. And the software companies told us in very frank terms, look, we'd love to do this, but we can't speak for the whole industry. If we do, we'll be accused of collusion. So we need the industry to tell us what to do. So basically, BuildingSMART was born, started with 12 companies in the USA, an architect, a contractor, a structural engineer, a mechanical electrical engineer, et cetera, a product manufacturer, happened to be somebody making mechanical equipment, and so on. We had 12 and a few software companies. 12 companies, took a year, spent our own money, and did a proof of concept with some very simple problems that could be solved. How do you fit a door into a wall? It seems really simple. And if you don't know construction, it's much more complex than you can imagine, because there's a thing called a rough opening. That's where the 2x4s stop. And then you got to have some shim space. And then there's finally a frame for the door, and the door has to fit inside the frame, et cetera. I won't bore you with that, but simply to say the 12 companies actually made this proof of concept, and we showed each other that we could communicate more completely between the architect, engineer, and contractor. We weren't thinking much beyond geometry at the time. We were thinking about how can I fit things together properly? And it turned out, I didn't know it at the time. We thought we could solve this in a couple of years and give the software companies the industry standard for how doors and windows and walls would fit together, and we'd have it all finished. 5 years, we're in and done. And what we also learned, however, is that computer technology kept galloping ahead. Computers got much more ability, capacity. And we, in addition to geometry, we began to understand, other characteristics can also be described for a door, a window, and a wall. Maybe my door has a fire rating and it's fitting into a wall that has a fire rating. Can we have the door and the wall cross-check each other? If the wall is a certain fire rating, the door has to be a certain fire rating. Can the computer begin to help us check things and avoid mistakes? Just simple things at first. Now, 25, 30 years later, the goalposts keep moving. Now, in addition to geometry and simple characteristics like fire rating, what about green? What about energy usage? Can we design a building and know from the computer as we're designing it how much energy that building is going to be using as we're actually making choices about where to put the walls and how many windows and what kind of windows and what kind of insulation to use? So if we have a green goal or energy usage, we can actually have the computer be our assistant to check us as we go. But all of these standards had to be created from industry consensus. So after the 12 companies did our proof of concept, we decided that we had to go on the road. We were smart enough to realize that the construction industry, buildings and infrastructure, but at the time the focus was buildings, the construction industry was becoming global. What do I mean? Well, even at a local level, if you're building a house in Denver, Colorado, or in Florida, or in California, you're using wood that probably comes from Canada. And if you're building an office building with an elevator, the elevator could just as easily be a Mitsubishi elevator from Japan as an Otis elevator. And even Otis elevators maybe are now being fabricated in China. So there was an international marketplace for products that went into buildings. And there was a crying need, and I saw it at HOK working in different countries. Everybody has the same problems. No country has a lock on how to figure this. An airport in China has to operate pretty much like an airport anywhere else. So standards for how things fit together and work together, standards for how to measure energy consumption, greenness, a way to track products so that you know that the source of the product. If you want to do a building with embodied energy, so you want to know how much energy it took to create the wall panels, we can now track that by the computer. It's very sophisticated, but it requires standards to be created. So what is BuildingSMART and what do we do? We're not a software company. Software companies do a fine job. We are a standards organization. We create the standards that are offered then freely to software companies to build software compliance with our standard. And if software company A becomes compliant with our standards and software company B becomes compliant, we now have an ability for those two softwares that were designed and built by different companies, but using the same, complying with our standard, to connect, to interoperate, or to exchange information. That's it.
Is that's the word? Yes, interoperability?
I just as soon not use that word because it's so damn complicated. I like to think of just in computer information. Here's the deal. I have an iPhone. You might have an Android. Doesn't matter. I can phone you or text you, and you receive the message. And you know what? You don't have to be in one fixed location. You could be anywhere on the planet Earth, and the system for discovering where your phone is when I call your number, you might be in Timbuktu, it will find you. And that's because another organization that was put into being created a set of standards for how we organize numbering system for phones by country and by area code, etc. That's why. Otherwise, it doesn't work. That's a simple one.
That's a good
people
analogy.
Don't think about it now. I just want to connect. I want to call you, and I
It
don't
just happens.
dial it anymore. I don't click the numbers in. I just touch your name and bingo. So that's what we want for buildings.
Yeah, I was going to say, is that the end state vision for BuildingSMART? Is that however many years down the road, people who are designing, constructing,
Yep.
and operating, the design elements just
Yes.
work. Like they almost like the end state vision is that it becomes an assumption that everybody is the design elements are all speaking
Yes.
the same language, if you will.
Yes, it just
and
works,
it
and
just
it goes
works.
into the background. Again, that phone analogy I used of I want to call you or text you. At my end as a user, it's a very simple transaction. I just want to call you. Boom. And it works. I don't need to know all that detail and complexity, but somebody needs to know it. Somebody needs to figure it out and establish standards so that my phone can connect to yours. It's no different. Let's say there's an order of magnitude more complexity about it, but it's no different than my phone connecting to yours wherever you are on the planet and wherever I am. We can find each other and connect. So my goal in this as an architect is to liberate the architect. The architects, if I can just, let me wax philosophical here for a minute. What's the job of the architect? Well, when I went to university and studied architecture, I didn't do it because I wanted to manage complexity. I went into architecture because I loved buildings and I loved design. I wanted to design beautiful buildings for clients. I wanted to get, I wanted my buildings to be well regarded, well respected in towns and cities across the U.S. and eventually across the globe. I didn't want to spend my time trying to figure out how the Sam Hill, I'm going to get the ductwork and the piping up in the ceiling above my office ceiling to fit together in what's called a plenum, that space above the suspended ceiling. How does all that spaghetti of stuff fit together? So I don't want to spend my energy and time doing that. And I don't want to have a meeting with the contractor where they say, you dumb architects, you didn't give me enough room to fit all that stuff in. Well, yes, I did, but you didn't build it the way I showed you to build it. Well, now, in fact, it's not only allowing me to practice architecture, be more thoughtful about design. Why? Because smart software with ever more powerful computers can help keep track of the complexity and allow me to be more creative with my work. And I can design better buildings because I can be more thoughtful about design and leave the complexity to the computer and the smart software that I've been using. And I get my choice. I can use the software of my choice as an architect, and my structural engineer can use the software of his or her choice, and they can still talk to each other and exchange information. If you were a geek, you'd say they can have full data exchange. I don't even like that because I think it's kind of like my phone connects to your phone, so that I can do business with you or have a friendly conversation without being a computer expert.
Yep.
I just want to talk. I just want to design a building. But I want all these smart systems around me to help me do my work.
So is it within the purview of BuildingSMART? So for instance, like from what I'm hearing, specifically on the infrastructure side and machine control, is that there is a gap between being able to design with the appropriate design breaks to be able to move it into the machine control. So essentially a contractor is getting the design from an engineer and then having to redesign it with the appropriate break. So is it within BuildingSMART to say, no, this is like now across the board, machine control is that new developing technology that you're talking about, and we have to be able to have the correct standards and understanding on how to do it correctly.
When I started, I was thinking much too small. I was thinking, can I somehow get something to help me with fitting all the ductwork and the piping in the ceiling over my head? We now understand it's not just a design problem. It's a construction problem, and it's a fabrication problem. The fabrication is done in a factory somewhere more
Yeah, good
often
point.
than not by machines that are driven by a computer. Well, hey, I'm using a computer to design. How about if I just communicate directly through to the computer that's going to build a component for my building? Well, if I want to do that, I have to know about manufacturing tolerances and what you can do with metal or plastic or aluminum, etc. And I don't know that, so I need the computer to help me understand what that is. In the days when I was trained, we had architects that did first design drawings on sheets of paper, and that's the floor plans and the elevations and the cross sections, and we'd usually do a pretty perspective for our clients to see what our building looked like. Then I would do construction drawings, which are much more detailed. People sometimes call them blueprints, much more detailed, and with a companion of specifications. I don't want to get too wonky here, but some things are better described with a picture, a drawing, and some things are better described in words. And we have to untangle that and tell the computer the best way to understand something. So let me give you an example. If I'm describing that door, that smart door, I can easily tell the computer the geometry of the door. That's what it looks like with a picture. It's 6 feet 8 inches high, and it's 3 feet wide, and it's 1 3/4 inches thick. Well, then if it's a wood door, I need to tell the computer, I need to have a specification, easier to describe in words, like I want 2 coats of varnish on that wood. I want it to be stained with a certain kind of oak stain. I want the varnish and the stain mixture to be a certain proportion. I want it applied with light sanding between. Those are all better described in words. Computers are good with words. Computers are good with geometry, but they have to be taught. They have to be taught, and we have to have a standard for how we're teaching a computer to do this. So Building Smart has chapters around the world, and we have committees of people, literally from different countries. We've adopted English as our common language inside of Building Smart for convenience. Again, why? Well, because it works. We want something that simple, works. And in our conversations, we finally, by consensus, develop what is the right way to mix paint, or what is the right way to describe a door or door hardware. And there are thousands of objects that make up a building, and each of those objects has characteristics and it has relationships with other objects. Can we describe that in words in words that we can agree on, and then can we convert that into something the computer can understand? We do that with something that is also quite wonky, industry foundation classes, or IFCs. That's computer language that the computer can understand. And it can be in any code. And I got so frustrated with it because it was a bunch of computer geek people talking back and forth. I invented a new name for IFCs, and I want everybody to pay attention. This is not difficult. IFCs are created by teams of people that work together across the world, building a consensus. In order to really work cooperatively, because when we first started, the Germans didn't like the French too much, and nobody was sure that they liked the Japanese, and nobody trusted the Americans, until finally it became, it's just Patrick and Tom and Thomas from Germany and Francois from France, and we became friends. We had a few beers at night, and once we became friends and trusted each other, we could actually do this work of creating joint standards, because it was. So I renamed IFCs the International Friendship Club, and there's more than a grain of truth in it, that we needed people to become friends first and build international standards after that. And so that's become a key ingredient of what we're like in Building Smart. It's a bunch of people that call each other by their first name. Yeah, what country you're from is less important than what you can contribute to the body of knowledge that we've adopted. And once we adopt this knowledge, I'm sorry, I'm running all over the place here. Once we adopt this knowledge inside of BuildingSMART and make it our standard, then we kick it up to ISO. And ISO, International Standards Organization, is a international standards body headquartered in Geneva, Switzerland, that is the granddaddy of standards organizations on the planet Earth. And ISO then has committees that review our standards, and they become adopted as ISO standards. Then they can be adopted by the standards organizations in each country. And that is what's happened now. IFC standards have become ISO standards. They've been adopted in most of Western Europe, China, Japan, Australia, most of the Middle East countries. In the United States, some, and it's growing. GSA, the General Services Administration of the federal government, the arm of the feds that builds buildings, they've adopted IFCs as their standard. They said, if we want a new building designed, it has to be IFC compatible. What that means is we want the architects, the engineers, and the contractors to work in an open BIM format using IFC standards to exchange data. Why? Well, lots of reasons, but
what's holding it back right now, Patrick? What's holding it back within the United States?
I think what's holding it back is that people don't understand what I'm telling you. They don't understand it as completely as possible. The larger architects, the larger contractors, the larger engineering firms all get it. They've adopted it internally. HOK adopted open BIM standards a couple of decades ago, partly because I was there, but partly because it makes good sense. We want to be able to communicate with our neighbors, our partners on projects. And the simplest way to do that is to adopt the IFC standard, buy software that is IFC compliant so that we can talk and work with anybody as long as they've done the same. The alternative to that is proprietary software. And proprietary software we think is a dead end street. Proprietary software is made by one company, and it might be very good, it might be excellent, but then you're trapped into using that software for everything you do, and you might not find every feature that you need or want on proprietary software, and you wish that you could use the software that your buddy uses across town, and you can't. So open BIM, open software is a core value of BuildingSMART. We're an open, neutral organization. We give our IFC standard away to anyone who wants to build software to it. We test them for compliance, but we don't insist. We don't have the power of a government to insist. But governments around the world are beginning to adopt these standards. So GSA is adopted. AASHTO, the Association of State Highway and Transportation Officials, all 50 state highway departments have adopted IFCs for highway construction, for design, construction, and operation and maintenance of highways. Well, that's good. Now, what about locally? The places where we're not doing this are at certain state levels and certainly the local levels. And, design and construction is still mostly, for small work, is mostly still local. The local architect, the local contractor, the local building official in anywhere USA. Those people are going to struggle with this to get it in until finally probably at the state levels, there's going to be some kind of a mandate. If you want to build a new school, it must be IFC compliant work so that people can use the software of their choice. And there's another really good reason why it's IFC compliance is in addition to liberating so that every software user can play in this, there's another really good reason that I want to explain. If you're an owner of a building, a perfect example is an airport. Every airport in the country and in the world is constantly expanding or renovating. I don't think I've been to I've flown in and out of a lot of airports. There's always construction of some kind. And airports are plagued with, okay, we just built that new concourse 10 years ago. Now we need to extend it or renovate it. And we go back to the drawings that we had. The drawings are done, they're on pieces of paper. So let's go back to the software, because we were smart enough to get disks of the live software. And we find, well, gee, the software has now been upgraded to a new version and it's not backwards compatible with the old version, and we can't get the data. So we have to hire an architect or an engineer to survey the old work and get some new drawings for us to show the conditions. Well, that's like throwing money away. You have to. So can we find a way to store information that'll still be good years or even decades later? Yes, we can actually store files as IFC files. And IFC files can be read. They are backwards compatible. It's a bit like, and again, I'm going to give you an analogy, kind of like the phone analogy. It's a bit like PDF files, where you can open a PDF file that's very old or very new, and it still works. So IFC files are like that. We made sure that IFC files can be reused and reopened, even with later versions and so on. Right now, we're just publishing version 4.3 of the IFC standard, but we can still open up the first version, which was IFC 0.5, because it's backwards compatible. So if you're an owner and you do a lot of your hospital group, those are always under construction as well. Airport, maybe a university campus, you're constantly changing. Well, wouldn't it be great if you had the information so you were up to date the next time you wanted to renovate or change or modify something in your building? So forgive me, I'm talking a lot. I get excited about this because I think it's the way that the whole world needs to go. So I'm like the country preacher. I want everybody to come to my church.
This is perfect, Patrick. I have this list of questions that I wanted to make sure that we talked about, but you've been like, I've been skipping over. I'm like, nope, he answered that one for me. So you've done a fantastic job. Fantastic job. And Patrick, believe it or not, we're actually at time. This could easily be a 5-part podcast with the amount of information that you could provide for us. But I have one last question that it'll be well, it's not necessarily going to be a construction question or a building smart question. Maybe it is. We at the end of every episode, we ask our guests, what is a motto that you live by or a motto that you find interesting? For example, and I'm going to go back to your alma mater, the University of Illinois Urbana-Champaign, which is the. Do you know what their do you remember what their motto was?
Go ahead, please enlighten me.
It's I have the benefit of Google to help me ahead of time, but it is learning and labor. That was their motto. So I ask you, what's a motto that you live by, or something that you find interesting?
It's live every day fully. When I stepped down from HOK after 50 years, I was in my 70s. It had been a wonderful experience. People said, "Oh, you're going to retire finally." No, I'm going to repurpose. I have other things to do. So I've in the 5 years now, just the 5th year, I've written a book about HOK. I'm beginning one on BuildingSMART. And I continue as international chairman of BuildingSMART. My wife and I founded a nonprofit here in our hometown to help out with certain things. Life is rich and full, and I'm not ready for a rocking chair. I don't have time for the golf even. There's too much to do. So I love being helpful, and I love figuring things out that are helpful. So that's mine. Is life is meant to be lived fully, and that's my wife and I both are bound in that same direction. She is an architect, by the way, and I was very blessed to meet her when I transferred to San Francisco.
That's wonderful.
Met her there 49 years ago, and we've been married 47 years. So HOK, I like to say HOK has provided pretty much everything I needed in my life, including my wife.
That's awesome. Well, thank you so much. With regards to your book, and correct me if I've got the name of it wrong. That's Designing a World-Class Architecture Firm. Is that the name of it?
Yes, you can Google it. I happen to have.
And where can
the book here, Designing a World-Class Architecture Firm: The People, Stories, and Strategies Behind HOK. You can Google it. You can also get it at my website, MacLeamy.com, or at any good architecture bookstore will have it or can get it for you. But thank you for that.
No problem. So that is our show for this time around. Patrick MacLeamy, thank you so much, founder and chairman of BuildingSMART, bringing us all up to speed on what that mission was. This was a fantastic episode. I know I learned a lot. So from the bottom of my heart, thank you so much for the time today. And thank you to everybody that tuned in, that's listening, that's watching.
Thank you very much.
Until next time.
Thank you for joining us for this episode of the Connected Construction Show. For more information, visit us at connectedconstructionshow.com.